Welcome to datascience.show, the podcast where data science meets executive leadership. We talk with top AI and analytics thought leaders about turning data into real business impact. If you're a C-level leader or data expert shaping the future, you're in the right place.
I'm your host, Mirko Peters. We explore how data science and AI drive real business impact, straight from the leaders making it happen. Today, building the AI runway, how executives plan multi-year capacity across data, talent, compute, and governance, so AI becomes repeatable, not episodic. Why this matters now: many organizations celebrate model wins, then stall because they run out of runway, not models. In this episode, I'll give a concise operational framework you can use to translate business outcomes into defensible 3-year capacity plans. Expect practical metrics, 3 forecasting templates, and the trade-offs you'll need to justify to your board.
To ground the advice, I'll reference a composite head of AI ops persona, Ava Chen, who represents enterprise-level operations across finance, retail, and platform companies scaling to millions of transactions a day. Ava's voice will surface the operational constraints we see in the field.
Thanks, Mirko. In my role, I run end-to-end AI delivery, data ingestion, feature pipelines, model serving, and governance. We support product teams and line of business owners and are measured on reliability, time to value, and risk reduction.
Ava's experience matters because capacity planning looks very different when you support production SLAs versus experimental notebooks. The rest of this episode treats the organization like a system. If one component, data, compute, talent, or governance, lags, the whole runway shortens.
Let's define the 5 runway components you must plan for: data, scale and velocity, features, engineering throughput and maintenance, compute and storage, training and inference, talent, skills and capacity, and governance, review cycles, compliance, and risk controls. I'll walk through metrics and a forecasting approach for each.
Start with outcomes. Pick the business KPI you care about. For example, reduce fraud losses by 20% or increase cross-sell conversion by 10%. Then reverse engineer required model throughput. How many predictions per day? How many training refreshes? And how many features will be active? Anchor capacity to these decision points, not to abstract model counts.
Data. Quantify dataset velocity and downstream maintenance. Metric 1, new records per day. Metric 2, change rate per feature. How often a feature's data distribution shifts. Example, if you ingest 10 million events a day and expect 5% growth per month, that's 10M times 1.05 to the month. Plan storage and ETL throughput for the high probability tail, not the median.
Practical rule. Size ingestion and storage for 18 months of data with a 20 to 30% safety margin if the business is growing rapidly. That margin is your runway for unexpected spikes, promotions, M&A, or seasonal events.
Features. Forecast engineering throughput. Use feature churn rate. How many features are created, modified, or retired per month, and feature maintenance cost in engineer days. Example template 1. Conservative. Assume 5 new features per month, 25% churn, and 2 engineer days per feature per month. Template 2. Bandwidth model. Map product requests to backlog and convert to FTE needs. Template 3. Outcome driven. Tie features directly to KPI impact and prioritize the top 20% that deliver 80% of value.
In practice, we run a quarterly feature health review. 2 things we track: downstream consumers per feature and cost to update. If a feature touches 10 services, its maintenance cost balloons. You must include that in your capacity math.
Compute and storage. Break costs into training and inference. Training cost equals number of retrains times dataset size times cost per GPU hour. Inference cost equals predictions per second times latency target times cost per inference. Build scenarios: conservative, expected, and stress. Example,
A model retrained weekly on 1 terabyte of data might need 200 GPU hours per retrain. Multiply by your cloud GPU rate and add storage I/O costs. Don't forget engineering time for orchestration and MLOps pipelines. These are not free.
Vendor versus build. Vendors can reduce time to first prediction, but often increase recurring costs when scaled. If you choose a managed provider, model the percent of work that remains, data plumbing, feature engineering, governance, and budget for that leftover work. A useful sanity check. If vendor eliminates 60% of engineering work, but you still need 40% expertise in-house, plan to retain those roles.
Size by capability, not headcount. Define roles: data engineers, feature engineers, ML engineers, platform SREs, governance specialists, and then assign throughput targets. Example throughput target: 1 feature owner can maintain 10 production features with automation, or 4 without. Convert your feature forecast into FTEs using those throughput targets, and add a 15 to 25% buffer for context switching and interruptions.
Governance. Bake capacity in. Governance effort is a function of review cadence and quality gates. Metric, governance hours per model per review cycle. If a model hits high-risk decisions, expect manual reviews, audit logging, and compliance time. Budget governance as a fixed % of total engineering capacity. In many regulated industries, that's 10 to 20%.
We found the single biggest surprise was feature maintenance. Teams underestimated cross-team dependencies. Our fix was a cross-functional SLA. Consumers must register dependency and accept deprecation windows. Otherwise, feature owners are overloaded.
Leadership and impact. Decision rights, budgeting cadence, and SLAs. Executives must set clear decision boundaries. What gets funded as Runway versus what's an experiment. I recommend a 2-track funding model, a 12-month Runway budget for production support, and a separate innovation fund for experiments. This avoids the common trap where successful experiments immediately compete for Runway resources. Measure ROI versus burn with decision-driven metrics. Cost per incremental prediction aligned to KPI lift, time to value for new features, and mean time to recover. Don't use model accuracy alone. Combine business impact, revenue saved or generated, with endurance metrics, operational uptime, feature MTTR, and governance completeness.
Governance trade-offs: strict controls reduce risk but slow time to market. A pragmatic model is risk-based governance. Low-risk scoring models get automated checks. Medium risk get periodic human review. High risk require formal sign-off. Allocate governance FTEs accordingly and track governance backlog as a capacity constraint.
Future outlook. Prepare for unexpected scale with scenario planning. Build a 12 to 36-month plan with 3 scenarios: conservative, expected, and growth. And run a sensitivity analysis on your biggest cost drivers, dataset growth and inference volume. Keep the plan adaptable by reviewing quarterly and by specifying migration triggers. E.g., when monthly predictions exceed X, move to a dedicated serving tier.
Vendor versus build. Again, decide using a break-even spreadsheet that includes hidden costs, integration, governance, and vendor lock-in risk. If you can demonstrate that in-house capability reduces per prediction cost or time to value sustainably after 18 to 36 months, build. Otherwise, partner and plan a transition path. A practical habit. Run a 30-60-day validation before taking a plan to the board. Validate your top 2 assumptions, dataset growth and feature throughput, with real telemetry. If either assumption breaks, revisit the plan before asking for material funding.
2 immediate actions you can take this week. 1. Run an outcomes to capacity mapping for one high-impact use case. Map KPI to predictions per day, retrain cadence, feature count, and compute needs. 2. Run a 30-day validation to test dataset velocity and one key throughput assumption. Those 2 moves alone separate speculation from fundable plans.
Final reflection from Ava. Prioritize decision-driven metrics and conservative safety margins. The Runway is not about eliminating uncertainty. It's about making uncertainty visible and fundable. That's the difference between models and value. If you found this episode valuable, subscribe and share it with your network. And let's connect on LinkedIn. I'm Mirko Peters. We'll be back with more conversations on how data science and AI create real business impact. Until next time.
Thanks for listening to datascience.show. If you found value in this episode, subscribe, share it with your network, and join us next time as we explore how data science drives smarter decisions and better business outcomes.